Now we will understand the vector integration. It's divided into 4 types of integrals. These are ordinary integrals, line integrals, surface integrals, and volume integrals. Starting with line integral. The general definition of a line integral is any integral that is evaluated along a curve. Line integral of vector point function, f of x, y, z over curve C from point A to B is defined by the integration along curve C, f, dot, dr is equals to the integration along limits, A to B of, f1, dx, plus f2, dy, plus f3, dz. Where f is the direct point function and dr is the displacement. And now let's proceed to our sample problems, in order to fully understand line integrals. Sample problem number 1. Evaluate the integration along curve C, f, dot, dr where f is equals to x squared I, plus y cubed j. And curve C is arc of parabola, y equals x squared in xy plane, from 0, 0, to 1, 1. First we will draw the curve parabola with the given equation y equals x squared. This is the xy plane, and we will find the line integral along this path. To find out the line integral we will use the formula. Integration along curve C, direct point function dot displacement. The given function is by the dot product of f dot dr, we get integration along C x squared dx, plus y cubed dy. Now we see that we have a single integration and 2 variables. By the 2 variables we have 2 limits. But due to the single integration we will have to convert it into a single variable. From the given formula, y equals x squared. By the derivation of y is dy equals 2x dx. We need to substitute the value of y equals x squared into the integration. Then we get x squared dx, plus substitute the value of y, x squared, raised to cube 2x dx. 0 to 1 integration equals x squared dx, plus 2x raised to 7 dx. And now we have a single variable and limits. Simplify the integration. X cubed over 3, limits 0 to 1 plus 2, x raised to 8 over 8, limits 0 to 1. And substitute the values. Equals 1 over 3 plus 2 over 8, equals 14 over 24. Simplified. 7 over 12. 7 over 12 is the line integral along path of the xy plane. Sample problem number 2. Find the work done in force field. F equals 3xy, I plus 5z, j plus 10x, k. Along curve x equals t squared plus 1. Y equals 2t squared, z equals t cubed from t equals 1 to t equals 2. In this problem we have 3 variables. But the limits given are in single variable. So we will directly integrate it. Along curve CF dot dr is equals to limits 1 to 2, 3xy dx minus 5z, dy plus 10x, dz. Now we need to find the value of dx, dy, and dz from the reference of x equals t squared plus 1. Y equals 2t squared, z equals t cube. First in x equals t squared plus 1, we find the derivative. We get dx equals 2t dt. Second equation is y equals 2t squared. Find the derivative. We get dy equals 4t dt. Third equation is z equals t cube. Find again the derivative. We get dz equals 3t squared dt. Now we have the values with us. Then we simply substitute the values to the equation. Equals limits 1 to 2. 3, t squared plus 1, 2t squared, 2t dt, minus 5, t cube, 4t dt, plus 10, t cube plus 1, 3t squared dt. Simply solve the equation. Equals 12 limits 1 to 2, t raised to 4 plus t squared, dt, minus 20, limits 1 to 2 t raised to 4, dt plus 30 limits 1 to 2, t raised to 4 plus t squared, dt. Find the integration and substitute the limits. Is equals 12 times t raised to 5 divided by 5, plus t raised to 3 divided by 3, limits 1 to 2, minus 20, times t raised to 5 divided by 5, limits 1 to 2, plus 30 times t raised to 5 divided by 5 plus t raised to 3 divided by 3, limits 1 to 2. Now we substitute the value of the limits. Equals 12 times 2 raised to 5 divided by 5, plus 2 raised to 3 divided by 3, minus 1/5 minus 1/3, minus 20 times 2 raised to 5 divided by 5 minus 1/5. Plus 30 times 2 raised to 5 divided by 5 plus 2 raised to 3 divided by 3, minus 1/5 minus 1/3. Now if you solve this it will be equals 171 minus 124 plus 256. The total answer must be equals to 303. 303 is the work done in the force field.